Hey everybody, this is lesson 23, the volume of a right prism. For our essential question, we're going to ask how do we find the volume of rectangular and triangular prisms? So specifically, we're working with these two shapes. Okay, the volume of a solid quantity is given by the number of units needed to fill the solid. So we've talked about perimeter, circumference, then we've talked about area, and now we're talking about volume. So underline that right there, the number of unit cubes needed to fill the solid. So if we're talking about cubic inches, you have to kind of imagine one like little 1-inch cubes. It's basically saying how many of these 1-inch cubes do we need to fill the solid. If we are talking about feet cubed or cubic feet, then you would have to imagine a cube with 1 foot on each side. So how many of those could fill the shape? Okay, most solids cannot be filled with unit cubes or assembled from cubes, yet they still have volume. So we're not actually making them from cubes, but they can still be filled up. Sometimes there's partials, but again, it's not all perfect cubes. They still are given in those measurement cubic units. Okay, the good thing is we don't actually have to make these solids in order to calculate their volume. One of the first interesting examples of a solid that cannot be assembled from cubes, but whose volume can still be calculated from a formula is a right triangular prism. So in order to get to the right triangular prism, we're first going to talk about rectangles and triangles and what kind of relationship they have. So what is the area of the square pictured on the right? We know that squares are length times width and that they have the same length and width, and in this case it's 6 by 6. So the area is 36 square units. Whenever they don't give you inches, feet, miles, you can just call it units. Now we're going to draw the diagonal joining the two given points, then darken the grid lines within the lower triangular region. What is the area? So you've seen this before. When you connect these two, you'll notice that this triangle here is half of the square that we just calculated. That's why the formula for triangle is 1/2 length times width. Or in this case, 1/2 6 times 6. And that would be half of 36, which is 18. You can also write units squared like this. So those mean the same thing, square units, units squared. If they don't tell us it's inches or feet, you still want to put a label on it because that's different than perimeter. Okay, now that we have talked about how the area of a square or rectangle is similar to, or what the relationship is to the area of a triangle, we're now going to talk about that same relationship using volume. So right now we're going to figure out the volume of the right prism pictured here. Okay, so we know that to find the volume of a rectangular prism, it's length times width times height. And we can see that the measurements are 6 by 6 still, but we also have a measurement of 1. So volume is 6 by 6 by 1, which means that that's 36 cubic units. Or that it took 36 cubes to make that shape. Okay, now what we're going to do is we're going to draw that same diagonal, and we're going to talk about how this works for triangular prisms. So if you can kind of imagine, and I'm even going to draw the back line there, try to imagine this as a triangular prism. It is now half of that. So now we can use the formula 1/2 length times width times height. So the volume of this one would be 1/2 6 times 6 times 1. Okay, and that would be half of 36, which is 18 cubic units. Don't get that confused with area, okay? Just because the number is 18 for both doesn't mean that it's talking about the same thing. 18 square units would be a flat surface. 18 cubic units would mean that that's how much space it takes up, or that's how much a container could be filled. Okay, what about if we took a triangular prism very similar to this one here, and we're going to create this to have 5 times the volume. What this is going to look like, is we're actually going to create a higher length. We want 5 times the volume. So we actually want to make 5 rows. Forgive me if this is not drawn perfectly. So we have this one row here. Can you see that? Like it's 1 unit high. We're going to go ahead and make 4 more so that it's 5 units high. 1, 2, 3, 4. So now there's 1, 2, 3, 4, 5 units high. And then we can connect these lines. We can also show the lines here, if you can see. This is just to give you a visual on how many little cubes it would take. Okay, again, don't make fun of the lines. They're obviously not super straight. And then these ones are even harder to make because they're on diagonals. But that's about as good as it's going to get. You can see kind of what it would look like from there. Okay, so now we want to talk about the fact that we're still going to use volume equals 1/2 length times width times height. And this would be a good time to put this with your formulas. Okay, so this is volume of a triangular prism. Okay, don't just write it here. Remember, you want a place where you can access all of these formulas. So make sure that you put it where you've been keeping all your formulas. Okay, so the length and the width, we have the same from before. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now we have a height of not just 1, though. We have a height of 5. Okay, and if you look, it's the same as this one up here, except now it's not just 1 unit tall, it's 5 units tall. So really this is going to be 5 times bigger because I'm taking 1/2 of 6 times 6 times 5. And if you want to go ahead and pause and calculate that, we're going to get the final answer. Okay, did you get 90 cubic units? Okay, units cubed, it looks like that, or you can write cubic units. Anytime that you're given the units like millimeters, inches, miles, then you would use that instead of the word units. Okay, let's go ahead and try to calculate on page 179 the volume of the triangular prism. We're going to skip this part right here and go down to the example. Okay, now they're using this formula V equals capital B times H. Go ahead and write capital B means area of the base. Be careful when you think of the word base. Base doesn't always mean bottom. In fact, if this is a triangular prism, the triangle is the base. Okay, it's named after its base. The reason that they use capital B here, so for this one, capital B is 1/2 length times width. That's because to find the area of a triangle, I do 1/2 the length times the width. Then we multiply by the height, or the line that connects the two triangles. Okay, so to simplify this though, we are going to use the formula 1/2 length times width times height. Again, just to show you, this is the area of a triangle. 1/2 length times width is the area of a triangle. Okay, and then the height connects the two bases, or in this case, the two triangles. So just so you see where that formula comes from. So again, this is the area of the triangle. So don't worry, I'll clean this up and we're going to find the area of the part I just shaded in green. And then the H is the height. We're going to multiply by 6.5. Okay, so let's kind of clean it up and see if we can follow this formula. 1/2 length times width times height. So remember, for a triangle, length and width, they have to meet at a right angle. So highlight with your highlighter, color pen, something so that you can tell where the length and the width are. They meet at a right angle, which in this case, hopefully you can see it's 1/2 meter by 4 meters. And go ahead and draw that little right angle there so you can see why it's 1/2 and 4. So 1/2 times 4, or 4 times 1/2, either one, times the height. So the height connects the two triangles. That's the part that you have to be careful of. It's not always how tall it is. This one only gives us 3 numbers. So this one's not too tricky because they only give us 3 measurements. They give us the length, the width, and the height. So you're probably going to get the right answer on this even if you have the numbers switched. Okay, so 6.5. That's the line that connects the two triangles. So I'm actually going to highlight the 3 parts there. Do you see how that connects the two triangles? Okay, go ahead and calculate that and see what you get. It's actually 6.5. All the other numbers will cancel each other out, and we'll be left with 6.5 meters cubed. So go ahead and put that little 3 there so that you can tell its volume. Okay, so that is the example for volume of a right triangular prism. Okay, we're going to do a few examples together, and I'm going to have you try some on your own. So flip all the way to page 181. So turn the page. And don't cross anything off, okay? I know what I've assigned. I see lots of kids scribbling stuff through, but sometimes we go back to that or I assign it in class. So don't scribble stuff out. Okay, for lesson 23, I'm going to do the independent practice problems with you from page 181. We're going to do A and E, and then I'm going to have you try B and F. Now, F you have to be very careful of because you're going to have to pay attention to where the right angles are when it comes to finding the area of the triangular base. Okay, so for A, we're going to use volume equals length times width times height because it's a rectangular prism. Okay, go ahead and plug in. You can always pause it if you'd like. Pretty simple because they give you 7, 8, and 12.5. So there's really nothing to guess on here. So go ahead and calculate that and see what you get. Okay, did you get 700 centimeters cubed? Okay, go ahead and try B all by yourself. You can use 0.75 if you want to, but I'm going to leave mine in fraction form. Okay, unpause it when you're done. Okay, did you get 27/64 or 27/64 inches cubed? So not even a full cubic inch, which makes sense because these are all 3/4 on each side. So it's going to be less than 1 cubic inch if you think of it that way. Okay, let's talk about the triangular prisms. These are going to be 1/2 length times width, then multiply by the height. For this one, pay attention. I want you to highlight where the right angle is. 4 and 4 make the right angle. In fact, I want you to go over to letter F so that when you try this on your own, you can see that the triangle, they give you extra numbers here, but that the right angle is made from 2.5 and 9 3/25. Okay, back to letter E, the one that we're doing together. So 4 times 4 is where the right angle is, and then remember, the height connects the two triangular bases. So again, I want you to jump over to letter F and highlight the parts that connect the two triangular bases. So those are the lines that connect the two triangular bases in letter F. Okay, so for letter E, there's nothing to figure out because they just give it to you. It's 6 7/10. Those fractions can get really tiny. Okay, now pause it and calculate it. Did you get 53.6 centimeters cubed? That's 3/5, by the way. 0.6 is 3/5. So you could also have 53 3/5. Okay? Right, now for letter F. I want you to try plugging them in. So first you got to use the right formula. This is a triangular prism. You can always be labeling that too. Okay, I want you to plug in the 3 numbers that you think are the length, width, and height of this. I'm going to give you a hint. They give you 6 numbers. You only need 3 of those. Okay, so you have to be able to pick out the correct 3 numbers that you would need. So don't forget length and width meet at a right angle, and then the height connects the two triangular bases. So go ahead and try to plug them in, then unpause it and see if you got it right. Okay, so the ones that I used are 2.5 times 9 3/25 because those are the two in green here that meet at a right angle. And then we have 5 as the number that connects the triangles. That's what I have in purple. Okay, so now that you have that, now calculate it and see if you get it correct. Okay, it's 57 inches cubed. Hopefully you got that, and hopefully you feel better now about how to find the volume of right prisms, specifically rectangular prisms and triangular prisms.